Hello and welcome back. So far we have understood Python, pandas and a little bit of descriptive statistics. Let us try to jump in and understand NumPy arrays. So NumPy is a module which helps us in handling homogeneous multidimensional arrays. So in other words, NumPy handles matrices in mathematics. So why matrices and why multidimensional arrays? In machine learning and deep learning, all the manipulations happen using matrix, linear algebraic manipulations. So to make our life easy to do all those operations, NumPy actually is providing many methods and modules to handle these kinds of operations. So NumPy is providing many modules and methods which make our life easy in handling the linear algebraic operations like matrix multiplications and calculating inverses or calculating eigenvalues, eigenvectors or singular value decomposition. So we will understand all these concepts in the coming course. But NumPy actually provides us modules and methods to handle all these linear algebraic operations. So they generally handle homogeneous multidimensional arrays. So to import or to create NumPy arrays, we first need to import the module. These modules have been came as part of your Anaconda installation, and then we need to import NumPy as NP we need to say, and then to create a NumPy array we need to take a list with now I have taken 1, 2, 3, 4 values in a list and then passing the list to array, the array method which is present in the NumPy module. So that will actually create a NumPy array. So one dimensional array, and it actually looks like list but it's not. So when you actually look at the D type, type of the object, you will see the NumPy array object there. And then shape is actually giving you 4 comma, like in pandas data frames, it is actually giving that 4 values are there in the NumPy array. And then to create a 2-dimensional array, I have taken another list and created list of lists with first list and second list enclosed in another list. So I have created a list of lists and then passing this list of lists to np.array method, which actually is creating a 2-dimensional array. So let me execute the statement and see how it creates the 2-dimensional array. See that it created a 2-dimensional array with the first row 1-dimensional array and second row another 1-dimensional array enclosed in the rectangular brackets. So it's a 2-dimensional array. When I say the NumPy array.shape is actually giving me the dimensions of the NumPy array, 2 rows and 4 columns. Okay, that's the shape. And then D type is an attribute which actually gives you the data type of the NumPy array. Here in the first list and second list I have got integer values. So by default it created a NumPy array with all integers. If one of the objects or one of the items data type is float, it will convert the total NumPy arrays objects data type as float. I have taken 5.0 one value in the second list. If I create an array right now, it actually converted all data to float. If you say D type, it will give you a float 64. So it can handle heterogeneous data, but ultimately after creating the array, it becomes a homogeneous data type. Another example of the same is if I take out 8 and give ABC a string there, it is going to create a NumPy array, a 2-dimensional NumPy array with all strings. Let us see that. See that 1 enclosed inside bracket, inside colon, 2 enclosed in quotes, 3 enclosed in quotes. Everything became string type. If you try to look at the D type, it will give you U11. That's a UTA data type. Okay, it's a string data type. So like that, it's a homogeneous. It can handle homogeneous data. It takes heterogeneous data but converts into a homogeneous array ultimately. So if let us try to make it an integer array and then see other experiments also. So NumPy array.ndim will give you the dimensionality of the array. It's a 2-dimensional array, so it gave 2, and then size will give you number of items inside the array. Even if one of the items is a null value, what is a null value in NumPy? It's an NaN. np.nan if you give and try to create an array and try to see the data type or the dimensionality or size, you get 8. Even though the value is null, it is actually counting it as a value and it's giving the size as 8. It is actually the rows into columns is the size. Okay, so why am I showing this is, in pandas if you say count, it will not count the nulls, but in NumPy it actually counts nulls also. So I think you noted the point, right? So and then if you say type of a NumPy array, it gives you NumPy.nd array. ND array is the data type of the object. Okay, and then there are other methods also. There are many methods there in NumPy, but we are going to show some important methods which are going to be used as part of this course, or generally used more in the projects. So arrange and reshape are those kinds of methods. So arrange is like range in your Python. Range actually creates a values. If you say range of 10, it gives you a values from 0 to 9. So similarly in arrange also, if you pass 32 here, it actually gives you values from 0 to 31, but enclosed in a rectangular bracket. That's nothing but a NumPy array it gives. Arrange method actually gives you a NumPy array. Okay, range gives you a range object from 0 to 9. You can iterate through and do whatever, but arrange method in NumPy gives you a NumPy array of one-dimensional array. And in NumPy array, in arrange also you have got start, stop and step. I think you remember this. Where to start, it starts at 2, and where to stop, it stops at 32. Even though it is 32, it stops at 30 only, because the last value, even if it can generate, it's not going to generate it. Step is 2, that means it generates 2, 4, 6, 8 like that. So it generated around 15 numbers from 2 to 30, but it did not generate 32 because it's the last number. It is like slice indexing and slicing. The last index is not considered. Similarly, here also it will not consider. So you can actually use reshape method to convert a one-dimensional array to two-dimensional array. There are 15 numbers, so I can say reshape of 3, 4. The NP ARR 3 is the object with 15 values from 2 to 30, and then reshape method which actually takes the dimensions 3, 5, and it converts the one-dimensional array to two-dimensional array. So here the dimensions 3 and 5 should be multiple of the total length of the array or any dimensional array. The dimensions you specify in reshape should be a multiple of that original size. Okay, so you can actually say 5, 3 also, but you cannot say 2, 4 because 2 into 4 is 8. And there are 15 numbers there, it's going to throw error. So 5, 3, it will create 5 rows and 3 columns. If you know one dimension and other dimension you doesn't know, that also works. If you give -1, it actually knows that the second dimension is 3. Okay, so it created. If you give 3 here and give -5, -1, it knows that it need to create 5 columns there. So 3 rows we wanted, but how many columns we don't know. So -1 is given and it actually creates the 5 columns. And there are other methods like zeros, ones and empty and I. So zeros method will create an array with all zeros with the given dimensionality. The dimensionality must be passed as a tuple. See this, zeros is a method. Inside it we are passing a tuple 3, 4. So 3 rows and 4 columns, all zeros. Why do you need zeros? In deep learning and other areas, we may have to create arrays with zeros and may have to manipulate them. So for that, the zeros method is important to know. And then you can actually use ones method, which actually creates an array with all ones. So I have given 2, 3 and data type is int 16. If I execute this, it creates a 2 rows and 3 columns. And I can create a 3-dimensional array also. So 2, 3, 4 will create a 3-dimensional array with 3 by 4 dimensional matrices and 2 depth or channels. So it's going to be like this. Let me draw and show you. So the 3-dimensional array is going to be like this. So when I said ones of 2, 3, 4, in NumPy, channels are first. This 2 is the channels. What is channels? It is like, stack of plates, right? If you have, maybe, we try it. If you have a rectangle like this and another rectangle like this, this is called a channel. This is first channel, this is second channel. So there are 2 channels it created. Okay, and then the values are going to be like this. 3 rows and 4 columns. 3 rows and 4 columns. So same kind of array will be there. An array will get created behind, like that. Okay, so that's how it created. So here if you see, this is a one-dimensional array, this is another one-dimensional array, this is another one-dimensional array, enclosed inside these brackets, and then these brackets, and then that whole thing, this till here it is a 2-dimensional array, and till here it is a 2-dimensional array, and we have enclosed the total thing in another rectangular brackets. That's how the 3-dimensional array gets created. If you say 4-dimensional array, these 3-dimensional arrays will get enclosed inside another bracket. That's going to be a 4-dimensional array. If you have one more an array like this, and then you are enclosing those 2 arrays inside a rectangular brackets, then it's going to be a 4-dimensional array. So here we have seen 3-dimensional array, and we'll handle 4-dimensional, 5-dimensional arrays in deep learning. But for now, if you understand this part, channels first in Numpy array, and then how it creates, that's enough. That's good enough. So let's move on and understand what is the empty method. The empty method creates an array with all empty values. Generally, this is going to be zeros, but we don't know. Depending on memory situation, sometimes you may get numbers also here. So in general, I use zeros and ones methods a lot than empty method. And there is a method called identity matrix it creates. So I don't know whether you remember about identity matrix or not. In an identity matrix, the diagonal values are going to be 1 and all non-diagonal values are going to be 0. So let me execute this and show you what are diagonal values and what are non-diagonal values and the importance of identity matrix in matrices. So let me take a screenshot. So here if you see, the I of 3 created a 3 by 3 matrix. The identity matrix is always a square matrix. If you see these ones, these are all diagonal values, we call them as. These are all non-diagonal values. So non-diagonal values are zeros and diagonal values are ones. You call that matrix as identity matrix. What is the use of identity matrix? If you multiply any matrix with I or any I with any matrix, you get the same matrix. So here, the I is the identity matrix and A is another normal matrix. So when you multiply any matrix with I, you get the same matrix. It is like 1 in real numbers or normal numbers 1. You multiply any number with 1, you get the same number. But in matrices, identity matrix is that kind of a matrix. Let us see one example here with Numpy. So here I have created an array A, right? I have created an array like this. np.arrange of 9 will create 9 values from 0 to 8 and then reshaped it as 3 by 3 matrix because I wanted to multiply the 3 by 3 matrix with this identity matrix and see whether I am getting A or not. So I created A and then I created an identity matrix np.I of 3, right? And then I multiplied A with I. In Numpy there is a method to multiply 2 matrices. So what is matrix multiplication? I'll explain in a moment. But if you use dot method, it actually multiplies the 2 matrices A and I. See, we have got the same matrix. If you multiply I in A, you got the same matrix. This is called as matrix multiplication. Let us try to understand matrix multiplication with a simple example. So here I am going to take a matrix 1, 1, 2, 2 and then an identity matrix 1, 0, 0, 1. If I have to multiply, do the matrix multiplication of this, not the element-wise multiplication. Element-wise multiplication means multiplying this number with this number, this number with this number, this number with this number, and this number with this number. That is element-wise multiplication. If I am talking about matrix multiplication, that should be done like this. you need to multiply this row with this column. 1 into 1 plus 1 into 0. This row with this column and put it here. 1 into 0 plus 1 into 1. And again this row with this column. 2 into 1 plus 2 into 0. Again this row with this column. 2 into 0 plus 2 into 1. So the outcome is going to be 1 plus 0, 0 plus 1, 2 plus 0 and 0 plus 2. This is going to be 1, 1, 2, 2. Right? This is matrix multiplication. When I multiplied a matrix with an identity matrix, this is a two-dimensional matrix, so this is a two-dimensional identity matrix. When I multiplied, I have got the same matrix. So A into I is equal to I into A is equal to A. This is the concept in matrices. We need to understand matrices also a little bit. In our course, we will introduce mathematics wherever and whenever it is needed, as we have shown it in this example, simple example. That much is enough to become a good data scientist or a machine learning engineer. Thank you.